In this video, we will use another classic example to demonstrate recursion. This example is to compute Fibonacci numbers. Fibonacci numbers is a sequence of numbers that begins with 0 and 1. All these subsequent numbers are the previous two numbers add together. So look at this 8 is 3 plus 5. 13 is 5 plus 8. 21 is 8 plus 13. We're going to write a program to find out the Fibonacci number at any given index. So this is the index 0, this is index 10, this is the index 11. Now, how do you compute it? You can describe it using recursion. Is Fibonacci number at the given index is the previous two Fibonacci numbers add together. So at index minus 2, index minus 1. Now, when the index is 0, that number is 0. Index 1, that number is 1. So this recursive definition gives the recursive function. Right away, you can describe it as follows. If index is equal to 0, return 0. Else if index equal to 1, return 1. Else return fib index minus 1 plus index minus 2. So we're going to put this together in this test program. This is to prompt the user to read the index. Now display fib index. So here in fib index, so these are the best cases, stopping condition. So when these cases are true, the recursive function terminates, returns. And else here, we're going to reduce the problem into fib index minus 1 plus fib index minus 2. So the program is rather simple here. It is a straightforward translation from the mathematical definition. But when you trace the program, you're going to see it is very much involved behind the scene. So let's look at computing fib 4. What do you need to do for computing fib 4? You have to compute fib 3 plus fib 2. So both fib 3 and fib 2. In order to compute fib 3, you compute fib 2 and fib 1. In order to compute fib 2, you compute fib 1, fib 0. See, you're going to see this in many recursive calls. So there's a lot of redundancy here. When you compute fib 3, you compute fib 2. So, but here, you're going to separately, you have to compute fib 2 again. So there are a lot of redundancy. So this program is not efficient, is not a good candidate to solve using recursion. If you have this index like 100, you're going to see a lot of time to finish, to find the solution. In the later chapters, we will present an efficient program, and that takes linear time to find the Fibonacci number for a given index. For now, this is just a demonstration, see how recursion works, and you can also see recursion is not efficient for a lot of problems. Recursion is very good for the inherently recursive problems, but not for most of all the other problems. So we're learning a new technique. So you have a lot of techniques you can use when you write a program. So you use techniques to solve the problems appropriately. So now here we have this solution here. You can see this is the number of calls involved. For the number, at index n, this is 20, you're going to spend this 21,891 recursive calls. For this 50, you already have a huge number, and 100 is really a big number. Well, that is all for this section to demonstrate writing recursive function using the Fibonacci number as the example. We will see the next video with more examples. See you on the next video.